Hello friends, in last lecture we discussed the direction angles, direction cosines. So theorem based on that. So first we again discuss the direction angles, direction cosines. Suppose line L we consider in space. If this line makes angle alpha, angle beta, angle gamma with x-axis, y-axis and z-axis. So in diagram we cannot denote the notations. So we consider a line parallel to this line L which is passing through the origin. So the angle made by this line passing through the origin which is parallel to this line L. So the angle made by these two lines are same. Suppose this line OP which is parallel to this line L makes angle alpha with x-axis, makes angle beta with y-axis and make angle gamma with z-axis. So these alpha, beta, gamma are called direction angles. Here alpha, beta, gamma are called direction angles. So when we measure these angles with cosine ratio, that is cos alpha, cos beta, cos gamma, then these ratios cos alpha, cos beta, cos gamma are called direction cosines. So here this cos alpha denoted by L, cos beta denoted by M, cos gamma denoted by L. So in this way, if alpha, beta, gamma are the direction angles and we measure that direction angles in cosine ratio, then that cosine ratios are called cosines of that line, that is direction cosines of the line. Now we have to prove in this theorem. See the statement of theorem. If L, M, N are the direction cosine of a line, then L square plus M square plus N square equals to 1. Or we can say cos square alpha plus cos square beta plus cos square gamma equals to 1. That means we have to show this L square plus M square plus N square equals to 1 when L, M, N are the direction cosine of a given line. Now we consider vector along the given line. Let a bar equals to a1i plus a2j plus a3k be vectors, be any vector, be any non-zero vector along line. So first we consider here a vector which is along the given line. So suppose we consider here line OP or parallel line which is L. Suppose given line is L. So we consider here a vector A bar along this line. So we consider A bar equals to a1i, a2j plus a3k which is non-zero vector. So by the definition we know the angle between two vectors. If first vector is A bar, second vector is B bar, then by the definition of dot product, A bar dot B bar equals to magnitude of A bar into magnitude of B bar into angle between them in cos. So we write here, this is definition of scalar product if vectors are A and B and angle between them is theta. So we write there A bar dot B bar equals to magnitude of A into magnitude of B into cos theta. So we use this concept for writing the proof of this theorem. So we consider here, since I cap is unit vector along x-axis, so we can write here A bar dot I cap is equals to. So by definition we write here magnitude of A bar into magnitude of I cap into. Now we consider here angle between x-axis and the line as alpha, that is the angle between unit vector and line, because this unit vector I cap is along x-axis, that means the angle made by x-axis with line is same as angle made by the unit vector with that line. So we write here angle between them as cos alpha. So this is by definition. If we calculate this value A bar dot I cap, so we write here also A bar dot I cap is equals to, now substitute the value of vector A as A1I plus A2J plus A3K dot I cap. Now we use the dot product property, so we multiply by this unit vector I, so A1 I cap dot I cap plus A2 J cap dot I cap plus A3 K cap dot I cap. So from this we write I cap dot I cap is 1, so we get A1 into 1 plus A2 into 0, J dot I is 0, K dot I is 0, so we write here A2 into 0, A3 into 0, which is equals to A1 into 1 is A1 plus 0 plus 0, which is equals to A1. So A bar dot I cap is, we write this as A unit vector of I cap, which is 1, so A into 1 into cos alpha, which is equal to A cos alpha. Now this is the value of A bar dot I cap, which is A cos alpha. This is also the value of A bar dot I cap. So from these two we can say here A cos alpha is equal to A1. So denote this as equation number 1. Now we calculate the same quantity by two different ways. First by using the definition of dot product, and second by multiplying by that unit vector to that given vector. So in this way we can find the value of A cos alpha is equal to A1. Similarly, if we consider here unit vector J cap, which is along y-axis, so the angle made by this y-axis with this line is beta. That means this unit vector also make angle beta with this line. So we write here, since J cap is the unit vector along y-axis and make angle beta with the line. So again we use the definition. From that we write here A bar dot J cap is equals to magnitude of A bar into magnitude of J cap into cos beta. So we write here magnitude of A bar as A, magnitude of J cap, which is unit vector, so we write 1 into cos beta, which is equal to A cos beta. That means A bar dot J cap is equal to A cos beta. Similarly, by substituting the value of vector A, also A bar dot J cap is equal to, substitute the value of vector A as A1I, A2J, A3K dot J cap. Now multiply by unit vector J to each term, we get A1I dot J plus A2 J dot J plus A3 K dot K. Now from this I dot J is 0, so we write here A1 into 0, J dot J is 1, we write A2 into 1 plus A3 into, here K dot J. So here K dot j is 0, so we write a3 into 0. From this we can write this as first term is 0, last term is 0, so we write here a2. So again a bar dot j cap is a cos beta and a bar dot j cap is a2. So from this we can say that a cos beta equals to a2. So we write here a cos beta equals to a2. Denote that equation number second. Similarly, we consider k cap. K cap is unit vector along y axis. Y axis make angle gamma with given line. So that unit vector k cap also make angle gamma with line. So we write here similarly a cos gamma is equals to a3. Denote this as equation number 3. So from equation 1, equation 2, equation 3, we add these three equations. We require its square. So squaring and adding equation 1, 2, 3. So we write here squaring and adding equation 1, 2, 3. We get, after squaring we get here a square cos square alpha. First we consider equation 1, a square cos square alpha plus a square cos square beta, a square cos square beta plus a square cos square gamma, a square cos square gamma is equals to. Now make this square of right hand side, a1 square, then a2 square, then a3 square, and a1 square plus a2 square plus a3 square. Now see the theorem statement. We have to prove cos square alpha plus cos square beta plus cos square gamma equals to 1. That means here a square must get cancelled. So we take a square common from LHS. We write a square in bracket cos square alpha plus cos square beta plus cos square gamma is equals to here a1 square plus a2 square plus a3 square. So we denote this as equation number 4. Now we have to cancel this a square with this quantity so as to get 1. So see the consider vector. We consider a vector a bar. We consider a vector a bar equals to a1i plus a2j plus a3k. So take its magnitude, because a is its magnitude. So take the magnitude of vector a, which we get a1 square plus a2 square plus a3 square. This magnitude can be written as a only. So after squaring both sides, we can write here. We write here a equals to magnitude. Magnitude of a can be written as a. So squaring on both sides, we write in LHS as a square. In RHS, square and square root get cancelled. So we write a1 square plus a2 square plus a3 square. That means in equation 4, we can replace this a1 square plus a2 square plus a3 square by a square. So substitute that value. Therefore, from equation 4, a square in bracket cos square alpha plus cos square beta plus cos square gamma equals to, we replace this value by a square. So a square get cancelled. Therefore cos square alpha plus cos square beta plus cos square gamma equals to 1. Therefore we can replace this cos alpha by l, cos beta by m, cos gamma by n. So we write here l square plus m square plus n square equals to 1, which we have to prove. So in this way, just by the definition of scalar product and manual calculation, we can find l square plus m square plus n square equals to 1. So this is important theorem which asked many times in board exam. Now this question also asked in this way also. See, if L, M, N are the direction cosines of a line, then number 1 L square plus M square equals to 1, that is cos square alpha plus cos square beta plus cos square gamma equals to 1. And along with this, these two questions are also asked. Second, cos 2 alpha plus cos 2 beta plus cos 2 gamma is plus 1 equals to 0, or this also asked in this form, if this transferred to right hand side equals to minus 1. That means cos 2 alpha plus cos 2 beta plus cos 2 gamma equals to minus 1, or cos 2 alpha plus cos 2 beta plus cos 2 gamma plus 1 equals to 0. In this, sin square alpha plus sin square beta plus sin square gamma equals to 2. So first we see the proof of 1 which we already seen. So we come to the second question. We have to show cos 2 alpha plus cos 2 beta plus cos 2 gamma plus 1 equals to 0. So we consider here LHS. So we write answer of second, LHS is equals to cos 2 alpha plus cos 2 beta plus cos 2 gamma plus 1. So we use here double angle formula. We know the formula. Cos 2 theta is equals to 2 cos square theta minus 1. So we use here that formula. So we write here 2 cos square alpha. 2 cos square alpha minus 1 for first. 2 cos square beta minus 1 for this second. And 2 cos square gamma minus 1 and plus 1 this as it is. So collect the cos square terms. So we write here 2 cos square alpha, 2 cos square beta plus 2 cos square gamma. So we take here 2 common. We write here cos square alpha plus cos square beta plus cos square gamma. Now this minus 1 plus 1 get cancelled. Minus 1 which we write minus 2. So we use here relation of cos square alpha plus cos square beta plus cos square gamma which is equals to 1. So we replace this bracket by 1. So we get here 2 minus 2 which is equals to 0, which is RHS. So along with cos square alpha plus cos square beta plus cos square gamma equals to 1, if this question is asked, we have to write that question in this way. Now see the third question. We have to show sin square alpha plus sin square beta plus sin square gamma equals to 2. So we use the identity. Which identity we use? We use sin square theta plus cos square theta equals to 1. So from this we can find the value of sin theta in terms of cos theta. So transfer this cos square theta to right hand side. We get 1 minus cos square theta. So consider the LHS of question third. LHS is equals to sin square alpha plus sin square beta plus sin square gamma. Now sin square alpha can be replaced by 1 minus cos square alpha. Sin square beta can be replaced by 1 minus cos square beta, and this sin square gamma can be replaced by 1 minus cos square gamma. Now we add first 1 plus 1 plus 1 which is 3, and take minus sign common from cos square. So we write here cos square alpha plus cos square beta plus cos square gamma. Cos square alpha plus cos square beta plus cos square gamma is 1. So we write here 3 minus 1 which is equals to 2, which is RHS. So in this way question asked on this theorem.